Hi, welcome to Orozco's Lectures. I am Jose Orozco, and these are my lectures. This lecture is a Calculus 1 lecture. I hope you enjoy it.
This is chapter 5.7, and 5.7 is the natural log function and integration. All right, so here we go, theorem. And this is for the log rule of integration. And this is what it says. Let u be a differentiable function of x. Then we get the following. The integral of 1 over x dx is ln of absolute value of x plus c. Right? We know the derivative of ln is 1 over x, so this part should make sense. Similarly, the integral of 1 over u du will be ln of the absolute value of u plus c for the same reason, right? All right, cool. So let's get as many examples in as possible. So let's say we have the integral of 1 over 2x dx, right? But what we can do here is this 1/2 in here, we can factor it out. So we have 1/2 integral of 1 over x dx, and the integral of 1 over x is ln of x. So we have 1/2 ln of the absolute value of x plus c. Cool. So that's one way of doing this problem. Let's look at a slightly different way. The integral of 1 over 2x dx. Let's say that from the very beginning I said that u was equal to 2x. Then du would be 2 dx, so that dx is equal to du over 2. At this point, we get that this integral becomes 1 over u, right? Our 2x is our u. And instead of dx, we've got du over 2. So we get here, I'll write it as 1/2 integral of 1 over u du. And at this point, well, what does this become? This becomes 1/2 times ln of absolute value of u plus c. And we know the problem wasn't about u, so we say this is 1/2 ln of the absolute value of 2x plus c. But look at that. We got two different answers. 1/2 ln of x and 1/2 ln of 2x. Turns out these are the same answer. Let's see how come. This part over here. By the rules of log, I can expand this to be ln of the absolute value of 2 plus ln of the absolute value of x plus c. At that point, if I distribute this 1/2, I'm going to write it this way. I'm going to write it as 1/2 ln of the absolute value of x plus 1/2 ln of the absolute value of 2 plus c. But notice here that 1/2 ln of the absolute value of 2, that's some number, right? Because ln of 2, that's an actual value, times 1/2, that's some other number. So what we can do is we can declare a new c, right? And what we can say here, our final answer would be 1/2 ln of the absolute value of x plus that new c, which in here represents that part. But it's just in general some other constant. So now we've got the same exact solution as up here. So the point here is that sometimes your final answer might look a little bit different. That doesn't mean it's wrong. All right. So that's something to keep in mind with these integrals. All right. So that's A. B. Let's say we have the integral of 1 over 3x plus 2 dx. All right. So in here, I'm going to make that entire denominator our u, so that our du is just 3 dx, so that our dx is just du over 3. Cool. At this point, we get the integral of 1 over u times dx was du over 3. I'm going to put the 1/3 on the outside, so we have 1/3 integral of 1 over u du. And at this point, this becomes 1/3 times ln of the absolute value of u plus c. But we know what the value of u was, right? So we have 1/3 ln of the absolute value of 3x plus 2 plus c. All right. Cool. Next one. Let's say that we have the integral of x over x squared minus 3 dx. I'm going to let the denominator be our u, x squared minus 3, so that du is 2x dx, so that we can say that dx is du over 2x. At this point, our integral becomes, well, this x, we did not use it for our substitution. X squared minus 3, that was our substitution. Dx is du over 2x. At that point, we see that the x's cancel each other out. So what we really have here is just the integral of 1 over u du with a 1/2 on the front, right? And at this point, this becomes 1/2 ln of absolute value of u plus c, which is, well, we know the problem wasn't about u, it was about our x. So we have 1/2 ln of the absolute value of x squared minus 3 plus c. Next one, d. The integral of 4x cubed plus 3 over x to the 4th plus 3x plus 9 dx. Alright, so in here, look at my denominator. The derivative of the denominator is the numerator. So I can say here, if I let u be the denominator, x to the 4th plus 3x plus 9, then du would be 4x cubed plus 3 dx. So that dx is du over 4x cubed plus 3. At that point, we can say our integral becomes now the integral of this 4x cubed. That was not part of our substitution. So 4x cubed plus 3. This denominator, that was our substitution. And instead of dx here, we have du over 4x cubed plus 3. And at that point, we see the 4x cubed plus 3's cancel each other out. So we have the integral of 1 over u du, giving us ln of the absolute value of u plus c. But the problem wasn't about u, so we have ln of the absolute value of x to the 4th plus 3x plus 9 plus c. Alright, next one. E. Let's say we have the integral of x squared minus 4 over x dx. In here, what can we do? Well, I have a fraction, right? So I'm going to split up that fraction. So I'm going to write it as x squared over x, which is just x, minus 4 over x dx. And now what do we get? Well, the integral of x is x squared over 2 minus the integral of 4 over x is going to be 4 ln of the absolute value of x plus c. So we didn't actually need to do a u substitution there. All right. If we really wanted to, we could bring this 4 up here as the exponent, but there's no real reason for that. So f. Let's say we have the integral of ln of x squared over x dx. Well, in here, if I let u be equal to ln of x, then du would be 1 over x dx, so that dx is equal to x du. At that point, this integral becomes, well, ln of x, that was my substitution, so I have u squared. This x, we did not use it for our substitution, so it's still there. This dx was x du. And at that point, we see that the x's cancel each other out, giving us the integral of u squared, which is u cubed over 3 plus c. At that point, we say the problem was not about u, so we have here ln of x cubed over 3 plus c, and that's a cube there. Cool. All right. Next one. Let's say we have the integral of 1 over x ln of x dx. If I let u be equal to ln of x, then du will be 1 over x dx. So the dx is equal to x du. What does that do for us? So we end up with this integral. The integral of 1 over this x, did not use it for our substitution. This ln of x, that was our substitution. This dx, that's x du. So at that point, the x's cancel each other out, so we have the integral of 1 over u, giving us ln of the absolute value of u plus c. But we know the problem was not about u, so we have here ln of the absolute value of ln of x plus c. Next one, h. Let's say that we have the integral of 2x over x minus 1 squared dx. All right, so what do we get here? Let's see, let's make our u be x minus 1. At that point, our du would just be dx, so that this thing becomes, well, let's see, the integral of this 2x we didn't use for our substitution. This x minus 1, that was our u, so we have u squared, and this dx was just du. But look at that, we've got x's and u's. We want to make sure that we don't do that, right? We want to make sure that it's all in terms of one variable here. So what can we do? Well, from this line right here, if I solve for x, I can say that x is equal to u plus 1. So what we get really here is, well, I'll put this 2 on the outside. So we get 2 times the integral of x. X was u plus 1 over u squared du. At that point, I'm going to rewrite this as 2 times the integral of u over u squared is 1 over u, and u over 1 over u squared is the same thing as saying u to the negative 2 du. So what do we get? Well, the integral of 1 over u is ln of the absolute value of u, plus the integral of u to the negative 2 is u to the negative 1 over negative 1, right? Add 1 to the exponent, divide by the new exponent, plus c. But the problem was not about u. So what we have to say here is this becomes 2 times ln of the absolute value of, well, what was our u? Our u was x minus 1. So x minus 1. I'm going to make this a minus 1 over, right, instead of u to the negative 1, I'm looking at it as being on the bottom, and this negative 1 makes that plus into a minus. So I have a u on the bottom, and u was x minus 1. And then we have that plus c. If we really wanted to, we could distribute this too. I'll leave it as is. All right, so that was h. All right, so now let's talk a little bit about some other trig integrals. All right. So integrals of basic trig functions. So, I mean, we already know a couple of them, right? The integral of sine is negative cosine. The integral of cosine is sine. This should have been du's. So it is sine. The integral of tangent. The integral of tangent is negative ln of the absolute value of cosine of u plus c. All right. The integral of secant, that's ln of the absolute value of secant of u plus tan of u plus c. The absolute value of cotangent of u, that will be ln of the absolute value of tan of u plus c. And the integral of cosecant, hold on, oh no, that's fine. The integral of cosecant of u would be negative ln of the absolute value of cosecant of u plus cotangent of u plus c. All right, so in here, I'm going to prove 2 of these. I'm going to prove those 2, and there will be examples. So that's for tangent, so let's start with that. So example I. So let's say that I had the integral of tangent of x dx. Well, in here, tangent of x can be rewritten to be sine over cosine, right? So let's see what we can do here. I'm going to start with making sine u. So let's see. U is sine of x. Then at that point, du would be cosine of x dx. So that dx is equal to du over cosine of x. And then what does this become? Well, this becomes the integral of sine. Sine was our u over cosine. Cosine was not used at all for a substitution. Dx, that was du over cosine of x. So what we really have here is the integral of u squared over cosine squared of x du. Now that's an issue, right? Because we have x's and u's. And we don't like to mix u with x. So what we want to do here is, how can we rewrite cosine squared? Well, cosine squared can be rewritten as 1 minus sine squared of x, right? Du. And why do I want that? Because, well, now sine is u. So what I can do here is I can rewrite this as the integral of u squared over 1 minus u squared du. At this point, I can, well, hold on. When did this become u squared? I have no idea. Way better, right? It was always just u. All right. At this point, what do we need to do here? Well, we need to make a substitution, and it's technically a u substitution, but we can't use u again because we're already using u. So let's say that we put in t. Let's say t is 1 minus u squared, so that dt, it would be negative 2u du. So that du is just 1 over negative 2u dt, right? And at that point, what do we do here? Well, let's see. This integral becomes now the integral of u. We didn't use u for a substitution, so it's still there. 1 minus u squared, that was our substitution, so that's t. Du became dt over negative 2u. At that point, we see that the u's cancel out. So what do we get? Well, really this negative 2 is going to be a negative 1/2 on the outside. And then we have the integral of t of 1 over t dt. That's ln of the absolute value of t plus c. But now, what was t? Well, t was 1 minus u squared. So we have here really is negative 1/2 ln of the absolute value of 1 minus u squared plus c. And then, well, the problem wasn't about u, right? So how do we rewrite that? Well, we can say negative 1/2 ln of the absolute value of 1 minus, what was our u? Our u was sine of x. So what we can say now is we have 1 minus sine squared of x plus c. But now, what's 1 minus sine squared? 1 minus sine squared is cosine squared. So I have ln of absolute value of cosine squared of x plus c. And then we know from rules of logs that this squared can be put to the front. So the square and the 1/2 cancel each other out. So I just have negative ln of absolute value of cosine of x plus c. And there we go. That's our final answer, right? That's what we said the integral of tangent was. Negative ln of cosine of u. But in this case, we were using x. Now, I want to redo this problem in a slightly different way. And here we let u be sine, right? So let's do I star. Let's say that, so we have the integral of tan of x dx, right? First step is the same. Write it as sine over cosine. If I let u be cosine instead, then du would be negative sine of x dx, so that dx is equal to 1 over negative sine of x du. At that point, what do we get? Well, this then becomes the integral of sine. Sine was not part of my substitution, so it's still there. Cosine was my substitution. Dx was 1 over negative sine of x. I'm going to put the negative on the outside, and we have 1 over sine of x du. At that point, we see that the sine of x's cancel each other out, so I have negative integral of 1 over u du, giving me negative ln of the absolute value of u plus c. but we know the problem was not about u. It was about cosine. So we have negative ln of the absolute value of cosine of x plus c. Look at that, same answer, but way shorter, way shorter. So my point here is that, well, you wanna try to look ahead and see which substitution might work better, right? In general, when we have ratios of sine and cosine, it is usually better to make the denominator the u. All right. All right. I'll leave it as that. So that was I. J. Let's say that I had the integral of secant of x dx. All right. Now, here for the integral of secant, as well as the integral of cosecant, let's look at what we're supposed to get as our answer. For integral of secant, we have this ln of secant u plus tan u. For integral of cosecant, we have negative ln of cosecant u plus cotangent of u. So the question here is, how do we come up with that inside there? Right? How do we go from here to here? Well, it's a very tricky way to do this. There's always two things you can do to any math problem, no matter what they are. The two things are multiply by 1 and add 0. In this case, I'm going to multiply by 1. But the one that I'm going to multiply by is going to be secant of x plus tangent of x over secant of x plus tangent of x. Notice that fraction overall is just equal to 1. All right, so what does that really give us? Let's see. I'm going to rewrite this now as the integral of secant square of x plus secant x tan x. Right, I just distributed the secant. Secant times secant is secant squared. Secant times tangent is secant tangent. And at the bottom, I'm going to have just secant x plus tan of x dx. At this point, I'm going to say, well, let u be equal to secant of x plus tangent of x. Then du would be, well, the derivative of secant. Secant x tan x plus the derivative of tangent, secant squared of x, and all of that dx. And look at that. Our entire numerator is our entire differential here. So what can we do here? Well, we just said that the entire numerator was the differential, so that's du. Secant x plus tan x, that was our u. So I have du over u, the integral of du over u. So that's going to be just simply ln of the absolute value of u plus c, but we know what u was. So we say here ln is the absolute value of secant of x plus tangent of x plus c. All right. Now in here, this is not an easy thing to remember as far as what the 1 should be in this case, and it's not an easy thing to figure out. I do recommend that for the integral of secant, you just go ahead and memorize it. In fact, all these integrals, you should memorize them, but this is one of the ones that it's kind of hard to figure out on your own. With cosecant, it ends up being something similar, but instead of multiplying by secant plus tangent, you multiply by cosecant plus cotangent over cosecant plus cotangent, and the rest of the integral looks very much the same. But instead of secants and tangents, it will be cosecants and cotangents. All right, so that was J. K. Let's say I had the integral from 0 to pi over 4 of the square root of 1 minus sine squared of x dx. Alright, so what do we do here? Well, 1 minus sine squared, we can rewrite that, right? And here, I would not try to go ahead and do a u substitution because I see that I can simplify stuff here. So what I have here is the integral from 0 to pi over 4 of 1 minus sine squared is cosine squared. So I have the square root of cosine squared. At that point, the square root and the square cancel each other out. So I have the integral from 0 to pi over 4 of just cosine of x dx. And from there, we'll figure out the integral of cosine, which is sine, the value from 0 to pi over 4. Plug in the top value, sine of pi over 4, minus bottom value, sine of 0. Sine of pi over 4 is radical 2 over 2. Sine of 0 is just 0. In fact, I'll just do that. And our answer there is just radical 2 over 2. Cool. Next, L. Let's say we said find the average value of f of x being equal to the square root of tan squared plus 1 on the integral from 0 to pi over 4. Alright, so first we need to figure out what the average value formula was. And if you remember this, it's the average value of a function is 1 over b minus a times integral from a to b of f of x dx. And in this case, what does that mean? This means 1 over b minus a, so pi over 4 minus 0, right? Times the integral from 0 to pi over 4 of the square root of tan squared plus 1 dx. But tan squared plus 1, that's a Pythagorean identity. That's, so hold on, so we have 1 over pi over 4. It's a Pythagorean identity, and tan squared plus 1 is actually equal to secant squared. And now we have the square root of secant squared. We have 1 over 4 pi. Well, dividing by a fraction is the same as multiplying by the reciprocal. And then we have 0 to pi over 4. And we said, well, the square root of secant squared, we just said that was secant. And from there on, well, what was the integral of secant? Well, it was ln of the absolute value of secant plus tangent, and then all of this evaluated from 0 to pi over 4, right? And what does that give us? Well, let's see. I'm going to factor out this 4 pi, and we have, plug in the pi over 4, so I have ln of absolute value of secant of pi over 4 plus tangent of pi over 4 minus, plug in the 0, ln of the absolute value of secant of 0 plus tangent of 0. And let's see what we get for some of these values. Tangent of 0 is just 0. Secant of 0 is just 1. Tangent of pi over 4 is just 1. Secant of pi over 4 is 2 over radical 2, right? I'm thinking of this as secant is the reciprocal of cosine, right? And cosine of pi over 4 would be radical 2 over 2. So I just take the reciprocal, 2 over radical 2. But if I rationalize this, notice that radical 2 times radical 2 is just 2. So it cancels out that one. So I just end up with radical 2 overall, right? So what I'm saying is this cancels out with these two. Cool. So what do we get now? Let's see. We end up with this 4 over pi is still there. And we end up with ln of the absolute value of radical 2 plus 1, right? Radical 2 plus 1 minus 1 plus 0 is 0. So we have ln of the absolute, 1 plus 0 is 1. ln of the absolute value of 1. But ln of 1 is just 0. So our final answer here would just be 4 over pi times secant of the absolute value. But where did I get secant from? 4 over pi times ln of the absolute value of radical 2 plus 1. And that would be our final answer. Cool. So that was L. JKL. All right. I will end this section there. In fact, that is the end of 5.7. All right.
Wasn't that fun? If you think I made a mistake somewhere, you're probably right. Tell me all about it in the comments. If you feel you learned something from me in this video, hit the like button, hit the subscribe button, but more importantly, share it. Share this video with your classmates. And remember, you don't have to like math in order to be good at it. But you do have to be good at it. I am Jose Orozco. Goodbye.